Good day to everyone. My name is James Ryan E. Castañares, and for today, we are going to continue the report about the environmental impacts of building, specifically the site design strategy. So, what is a site design strategy? So, it is a strategy that considers the specific aspects of the design that may affect the buildability or logistics of constructing a project. It may also affect the health and safety aspects of the inhabitants of the building. So when we talk about site design strategies, these are strategies which are the sites can be organized in order to aid the heating, the lighting, the cooling, and the control of the noise in a building. So one example of a site design strategy is by Watson and Labs 1983 designs that are compared to their seasonal rows. So as you can see in the figure, this is the generic bioclimatic site design concepts and building strategies. So these building concepts enables or provides an effective design of a building. So for an example, the windbreaks. So during the winter season, the building has a minimized external heat flow because of the windbreaks. And it also has a minimized infiltration because the the building has a, protection from any external forces or any external winds. And next, for an example, the sun shading. So during the summer, the sun shading of a building or the design of a sun shading, it it provides a minimized solar gain, and it promotes a radiant cooling. So these generic bioclimatic site design concepts provides an effective building design. So next third type or another example of design strategy is the horizontal layer of a site. So this example is taken from the Boston City Hall, which is in 1969 by Kaliman, McKinnell, and Knowles. So in this type of strategy, a horizontal layer of a site. So the horizontal layer of a site is divided by four, which are the sky layer, near surface layer, and subsurface layer. So when we talk about subsurface layer, it is the isolation by enclosure. It often plays a supporting services role for a structure, either mechanical and electrical equipment. So in subsurface layer, these the parking and the mechanical equipment can be located, and also the data processing. And next is so when we talk about surface layer, it is the most varied and public level. So it is the most frequent public contact, which it consists of the entry and the lobby of a building. Next is the near surface layer. So when we talk about near surface layer, it has a detailed overview of surfaces activities, which is accessible by stairs. So in the Boston City Hall, this layer locates the mayor and council's office, council's chambers, and references, library, news, conferences, and exhibits. And lastly, the sky layer, which is an isolation by height. It is too far from the surface to see or hear, and it is also too high to climb using stairs regularly. So when we talk about sky layer, it is a least frequent public contact because of its height. Uh, uh, in the Boston City Hall, it Uh, it has a least frequent public contact of the public works, which consists of the housing, health administration, parks, and recreation buildings and redevelopment. So this type of site design strategy can be also implemented. So the information in the figure 3.6 and 3.7, we can see the application implemented or the planning of a building and its sites, which is the house designed by Frank Lloyd Wright in the 1940s, which we can see in the figure. So this type of house design has a direct gain of solar heat through its south-facing windows in winter, makes this an early example of a passive. So one example of how the information in figures 3.6 and 3.7 can be applied is the planning of a building and the site of a house designed by Frank Lloyd Wright in the 1940s. As you can see in the figure, this is the design by Frank Lloyd Wright. So this type of design or building has a direct gain of solar heat through its south-facing windows in winter, which makes this an early example of passive solar heating. By contrast, an active solar heating includes the collectors and the single-purpose storage volume for solar heat. So this house or building is known as the solar hemicycle. It was built in the 1948 near the Madison, Wisconsin. So the house stands on a rise in the prairie, particularly vulnerable to winter winds. As you can see in the figure, there is a rise of a land, which is the rise in the prairie. And during the construction of the building, the earth was scooped from in front of the south face of the house and burned against the entire curved north wall, almost to the roof level, as you can see in the figure. So, so the north wall is made up of stone. So it absorbs and stores winter solar radiation or heat. So as you can see in the figure, this house design is shorter in the north-south and longer in the east-west direction. So the elongation is typical of a passive solar design, which are able to store and use winter solar heat gain and thus profit from having a long south-facing glass walls to act as a passive collectors of solar or sun collectors, from what I said earlier. So in the solar hemicycle house or building, the protection from summer overheating is provided by an overhang alongside the south glass walls as well as by the shaded and cool thermal mass of the north stone berm wall combination. So the high windows in both the north and the south walls allow warm air to rise and escape. So this type of design protects the building from any type of solar or winter winds to enter the building. So from the design of the building, the wind only passes through the back side of the building because there is a high rise of building in the back, and it also provides a sun shading which enables or which protects the building from any solar heat. And also the front side of the building, which has a overlooking a sunken or sun-trapped circular lawn, which enables the solar or the sun to concentrate on the circular lawn. Design strategies enables to create an effective building due to its strategies being implemented on the building itself. It creates a better implementation or better effectivity towards any aspects of any external aspects the building may experience. So I think that is all. And thank you.